Welcome to Chapter 13, Part B, where we're going to discuss Chomsky's normal form. And Chomsky's normal form is a way to rewrite all of our context-free grammars so that we only use two kinds of productions, these two right here. Now, this one right here is called a live production. It consists of a non-terminal, as usual, on the left side, and two non-terminals on the right side. Remember, non-terminals are the capital letters that we need to replace with the terminals eventually to get a word. We call these live productions because they increase the length of our word. Each time we use a live production, our word is going to grow by one letter. Now, this right here is the dead production because it takes one non-terminal and turns it into a terminal letter, and we call it a dead production because that's the end of this non-terminal. We got the final result. Now, why would we want to do this? Would it be to make it more readable? No. Would it be to make it somehow better? No. There's no reason to do this except that we want to prove that we can do this for any context-free grammar. If we can do this for any context-free grammar, then we can write proofs knowing that there are just two productions that we need to worry about. So this is going to help us write proofs in the future. Now, would you want to take your context-free grammar and turn it into Chomsky's normal form to make it more understandable? Definitely not. It's not going to make it more understandable. It's going to make it more confusing and harder to figure out what the language is. But we just want to prove that we could take any context-free grammar and turn it into Chomsky's normal form. To do that, we're going to do it in three steps. One production that cannot exist is called a null production. And a null production is a non-terminal going to the null word, because obviously that's not one of these two, and there's no real good way to quickly convert this into one of these two productions. So we can't have any of these null productions. The next thing we need to do is get rid of unit productions, and that's when we have one non-terminal going to another non-terminal. So both of these are non-terminals, and we need at least two there, and it's hard to add another letter on here just for fun purposes or to try to convert this. So we need to get rid of all the unit productions in our grammar. Once we have these and these out, it becomes pretty straightforward to convert our context-free grammar into a grammar that looks like this. Now again, when we convert it, what we want is a new context-free grammar that accepts all the same words that the previous one, the original, does, and doesn't accept any more words. Well, except one. We are going to toss the null word out of any language. But when we do that, we'll just handle the proof in that case a certain way. But yes, we are going to change the grammar just a little bit by kicking the null word out, because there'd be no way to have it in when we're doing Chomsky's normal form. Okay, so now let's talk about killing null productions. So once again, a null production is when we have a non-terminal that goes to the null word. Okay, so this is what we're going to do is we're going to first just cross this out of our language. We don't want it anymore. But if we just do that, then we're going to change our language. And in fact, we might make it impossible to accept any words at all. If we look at this language right here, this is a palindrome. If we get rid of this production right here, S goes to the null word. If we get rid of it, then there's no way to get rid of the S out of the word, and there's no way to form the word. So as the first thing we want to do is cross that out, but then we have to modify all the productions that use or introduce that on the right side. Whenever we see this non-terminal, we create a new one. Now, we don't delete this one, we leave this one here, but we create a new production that has the non-terminal missing in it. So we create this new production. So we introduce it back in. Now this blah one is just whatever letters. It might be terminals or non-terminals that precede the non-terminal that we're getting rid of and also follow this non-terminal. So we just make this non-terminal disappear and it goes like that. So the thinking is if we have a word like A, B, S, B, A, and we want this thing to disappear, well, there was the last production that we used, like this right here. Instead of using this production to introduce this into our word, and then use this production to make the S disappear, we'll introduce a new production as S goes to B, and instead of using that one, we'll use the next one. So we'll get rid of the S in the same step in one step instead of introducing this and then getting rid of the S next. So how would this happen here? That we're using palindrome as an example. We notice that S goes to null. That's a null production. We got to get rid of it. So step 1, get rid of that. Step 2, introduce a new production rule. S goes to, and we're going to take this term that has S in it, and I kind of miswrote this. Just let me correct this real quick. That should be an A. Okay, so we're going to take this term right here, and we're going to add a new one with the S taken out. Okay, and then we're also going to add, we're going to look at this production that has S in it, and we're going to take the S out and create a new term that has just 2 B's in it. Okay, so now we have the same language almost without using the null word, and it will still define all palindromes, but the only word that we got rid of is the null word. So just a slight change, and remember, we're just doing this so that we can write proofs in the future, so we can handle this, the null word only as a special case in those proofs. So let's try one more example of a new context-free grammar that has a null production in it. Now let's say, so the step 1 is we want to get rid of that null production. So we get rid of that production. Then what we want to do is find all the productions that use it. So this is X goes to null. We have that one and that one. And we just add in a new production. In this case, right here, we'll add in a new production with just B in it. And in this case, we'll write a new production with the X gone, meaning we introduce the null word. And then we're like, ooh, we're done, except for now we have another null production. And you know what? If I get rid of it, then in this case, this is Y goes to that. If I get rid of it, then I'm going to reintroduce the null word back in here. And then I'd have to get rid of that null word, and it just kind of be a cycle over and over and over again. So in that case, we just have to modify it a little bit. And when you notice there's a cycle, we go ahead and we get rid of the null production. And then we realize that the Y, the X can get nulled out, and the Y indirectly, because the X could get nulled out, that the Y indirectly can get nulled out too. So we need to get rid of, we need to disappear both Y and X at the same time. So let me just repeat that. Because X can get nulled out, and X is right here, Y can get nulled out as well. So we kind of create a group of non-terminals that can get nulled out, and then we create new productions with them not in it. Now we leave the old ones in as well, but we create new productions with them not in it, ignoring the ones that would reintroduce a null production in there. So in this case, we would add the B because the X can disappear. And then we'd also add an AA because the Y can disappear. And then we don't bother getting rid of this production right here, or this production right here, because if we do, we just reintroduce the null word. But we do get rid of this one. So that's if there's some sort of cycle that can make more than one terminal disappear. We can't keep going on forever and reintroducing the null word. So we just have to create a group of symbols that can get nulled out, and then we make new rules with them not in there anymore. Okay, now let's focus on getting rid of unit productions. And unit productions are where we have where one non-terminal goes to another non-terminal. So we're going to do this in pretty much the same way we just killed the null productions. If A goes to B, we get rid of that unit production, but then anywhere in our terminal, in our production rules where we see A on the right side of the production, we introduce a new rule with B on the right side of that production. So in this case, we see that we have S goes to A, and then so since S goes to A, we basically replace S with A, and then A can be replaced with B. So we just add a new production saying S could go directly to B. Instead of S going to A and then to little b, we can have S go directly to little b. But this is a little more complicated example because A goes to B is another unit production, and then B goes back to S. So we kind of have this cycle of unit production. So this is kind of worst case scenario here where we have this cycle of productions that go and back to each other. So we really need to get rid of all of those productions. Okay, so now once we get rid of it, we just kind of have to carefully look through, make sure we don't modify this language, and add in the new rules that would need to be added in this case. So S that goes to A, and then A could go to a little b. So let's add in a little b production. S goes to little b. Then A can go to B, and B could go to little a. So we need to add in the little a on this case right here. Now B can go to S, and S could go to two little b's, so we can add the two little b's here. And you don't have to worry about the new productions that we've made, and because they're already taken care of from previous things. So, and now, but we also have S can go to A can go to B. So, then A could go to B, and B could go to little a. So we would need to add a little a onto that. And actually, I lied, we do need to worry about those. So we're actually going to say A could go to B, B could go to S. So little a has to introduce the two little b's on there. And one last thing, for the same reason, we'd have to add little a onto that. Now, if we look at this, this is kind of a silly thing because now that we've gotten rid of the unit productions right here, really we don't need this one and this one. We could just have S goes to that, or that. And it is a finite language, but this is kind of worst case scenario. So there is one more example in your book that you can look at of killing unit productions. You just kind of got to be careful, think your way through it, and add in those new productions as you get rid of the unit productions. Now we're going to finish our conversion to Chomsky's normal form. By the way, Chomsky is a linguist. He studied how humans can understand languages. He really wanted to try to figure out how did humans, when they hear words or see words written down, how did they parse and understand that? So he broke down languages into these grammars right here, and he didn't really know this at the time, but he laid the foundation for the invention of programming languages. With Chomsky's normal form, and these are higher level programming languages, not assembly, but higher level programming languages. He was able to kind of dictate algorithms that could understand our programming languages. So a lot of his work is really important in computer science. So let's go to Chomsky's normal form. Remember, we want live productions or dead productions. And the first rule when we're going to do this is if it isn't broken, don't fix it. So we're going to go ahead and find out all the productions that already are in one of these two forms. And I'm going to circle them. If you notice, we have this production goes to a little letter. So this one is okay. So when I circle it with this orange, that means it's already a production that is acceptable in Chomsky's normal form. Okay, so the next step that we're going to do is we're going to introduce new non-terminals for these right here. So whenever we see lowercase letters that are part of and have, we're a mix between lowercase letters and capital letters, in order to get rid of the lowercase letters, because you don't see, whenever we have non-terminals, it's just a pair of two non-terminals, so we can't have them mixed. So what I'm going to do is I'm going to introduce a new production rule X that goes to a little a, and Y that goes to a little b. And then up here, we can erase, anytime we see a little b, we can erase that and replace it with a y. And so let's go ahead and erase all of those. Okay, and now anytime we see a little a, we can replace that with an x. Okay, now after we've done that, we've fixed some of these productions so they now match this format right here, and I'll circle those in orange as well. So this one's okay, this one's okay, this one's okay, and this one's okay. So the two that still need fixing are these two because they have three non-terminals, not two. So to fix them, we just introduce a new production, and in this case, I will call this R1, and I'm going to take two of these letters and throw it into R1. So let's take the Y and the A, and let's throw it into R1, Y, A, and then we could go up here, erase those two letters, and replace them with the R1. That way, we have this down here, we replace this, and then we can add them together and we could get back to the YAA. And we're going to do another R2 for the XB that we can replace right here. Okay, and now that we've done that, these two productions are now in Chomsky's normal form. So now we have all of the productions in this context-free grammar. We have all the productions in this form right here. Now the book contains a proof saying that you can do this for any context-free grammar. So now we know whatever the grammar is, if it's a context-free grammar, we can convert it to Chomsky's normal form. So that means either a live production or a dead production. And after we do that, then there's other proofs that we can do that we're going to see later on in a couple of chapters that will show you how this is really convenient to make proofs knowing that there are only two kinds of productions that we need to worry about.